So this square has special characteristics. Okay, so let's look at what are the characteristics of this magic square. Okay, number one, the sum of all the numbers on each row, each column, and each diagonal are the same. Okay, so if you have a magic square like this, one minute now. Okay, so if you have a magic square like this is a square, right? All the sides are equal, so it's a square. Okay, so if you have a square like this, then the sum of each row, this plus this plus this, each row the sum is the same as the sum in each column and each diagonal. We have two diagonals here. Okay, so if the sum of all the numbers on each row, each column, and each diagonal are the same, then it's a magic square. Okay, so number two, the order of a magic square tells how many rows or columns it has. For example, this square here is a 3 by 3 magic square. When you say 3 by 3 magic square, it means that the order of this magic square is 3. Order 3 means 3 by 3. That means there are 3 squares on each side of the magic square. It has a dimension of 3. Okay. So a square with 3 rows, 3 columns is order 3. If the square has 4 rows and 4 columns, it is order 4. That means a 3 by 3 magic square has an order 3. 4 by 4 magic square, order 4. 5 by 5 magic square is order 5. Okay, that is what we mean by order. Okay, a square, number 3, a square consisting of consecutive numbers starting with 1 is sometimes known as a normal magic square. Okay, so if you have a square, okay, say for example this 3 by 3 magic square, there are 9 small squares here, right? Which means we can put in 9 numbers inside here. For example, say our numbers are like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 numbers here which we can arrange in this square. Okay, so for example, okay, let me just arrange it in the square first. Okay, okay, so I put in 9 numbers inside this magic square, and this magic square consists of consecutive numbers. See, 1, 2, 3. These are called consecutive numbers. After 3 is 4, after 4 is 5. Okay, and it starts with 1. If the magic square starts with 1 and all the numbers are consecutive numbers, then this magic square is also known as a normal magic square. Okay. A normal magic square of order n contains 1 to n squared integer, which means if this 3 by 3 magic square, if it's a normal magic square, then it contains the integers that it contains are 1, 2, 3 up to 3 square. So a 4 by 4 magic square, if it is a normal magic square, that means it starts with 1, 2 up till 4 square. How many numbers are there in a 4 by 4 magic square? How many numbers will there be in a 4 by 4 magic square?
16.
16, correct. 3 by 3, 3 square, 3 by 3 magic square, 9, okay? So in a 5 by 5 magic square, order 5, if this is a normal magic square, then it will start with 1, okay? 2 and 2, 5 squared. So there will be 25 numbers if this is a normal magic square. But a magic square does not need to start with 1 all the time, okay? It can start with other numbers as well. Okay? So far, okay? Okay, so they finished 3, yeah? Okay, now let's look at number 4, okay? The magic, okay, if our magic square is starting with 1, if it is a normal magic square, like we did earlier, okay? Let's take this as an example, huh? Okay, if it starts with 1, then how do we find the sum of each row, each column, and each diagonal? Okay, there is a formula that we can use, okay? And the formula to find the sum of each row, each column, and each diagonal is given as n multiplied by n squared plus 1 over 2. So for these numbers here, what is our n?
9.
Okay, n represents the order. So if n represents the order, what is n?
3.
Yes, there are 9 numbers here, right? 9 numbers. You look at the last number, 9. 9 is actually 3 squared. So the order here is 3. 9 numbers, you can put it into a 3 by 3 square. 3 by 3 square. So n here is 3. So it's n is 3, sorry, 3 square plus 1 over 2. How much is this? 3 times 3, 9. 9 plus 1, 10. 10 divided by 2, 5 times 3, 15. Okay, so which means that in a 3 by 3, okay, which means in a 3 by 3 magic square, the sum of all numbers in each row, each column, and each diagonal is 15. And this 15 is also known as the magic constant. Okay, so if the magic square is a normal magic square, to calculate, okay, or to determine the sum of numbers in any row, column, or diagonal, we use this formula, okay, n times n squared plus 1 divided by 2. But if your magic square starts with any other number, okay, then we use a different formula. We use this formula. The sum is equals to 1 over 2n times by 2a plus d into n squared minus 1. Okay, your n represents the order, a represents the first integer, okay, the first integer, the first digit, and d here is the difference. Okay, so the magic constant for nth order general magic square, starting with an integer a and with entries in an increasing arithmetic series with difference d between terms, is given as this. An arithmetic series is when the difference, when you keep on adding the numbers, and the difference is the same. For example, okay, let's look at this. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18. How many numbers are there here? 5, 6, 7, 8, 9. Okay, so I have 9 numbers here. What is the first number here?
2.
First number is
2.
2, right?
Yes.
Yes. So because the first number is 2, okay, so therefore A is equals to 2. And what is our n? N is equal to how many numbers here? 9. 9 I can put into a box 3 by 3. 3 by 3, right? 9 numbers go into a 3 by 3 magic square. So the order is 3. Okay. What is the difference? Difference between 2 and 4? Plus 2 here. 2. 2. So all the difference is the same. This is an arithmetic series. Okay. You plus 2 to build the series. Okay. The difference is 2. Okay. So D is equals to 2. So how do I count the sum here? So it is half, n here is 3. 2 times A is 2 plus D, the difference is 2, n square is 3 squared minus 1. Okay, so what do we get here? This is 3 over 2 into 2 times 2, 4. 4 plus 3 times 3, 9 minus 1, 8 times 2, 16 plus 4 is 20. So this is 30. 30 is also known as the magic constant. That means the sum of all the numbers in each row, each column, each diagonal will be 30. Okay? Do you understand this?
Yes.
So if your magic square starts with 1, okay, consecutive numbers, you can use this formula, okay? You can use this formula. If your magic square doesn't start with 1, then you use this formula. This is to find the magic constant. You find the magic constant so that when you have put in the numbers into the magic square, you can calculate the sum for each row, each column, and each diagonal to determine that it is the same. If it is the same, then it's a magic square. If it's not, then it's not a magic square. Okay? So we have looked at the characteristics of a magic square and the formulas on how to calculate the sum for each row, each column, and each diagonal. Okay? Okay. The other thing that we want to tell you is that there are 3 types of magic squares. Okay? There are 3 types of magic squares. We have a singly even order magic square. This is singly even order. We have doubly even order magic squares, and we have odd magic squares. Okay, 3 by 3 is an odd number. 3 is an odd number, so this is an odd magic square. Okay, then we have even order magic squares. This is odd order magic square. These two, number 1 and 2, are even order magic squares. There are 2 types: singly even or doubly even. Okay, so we will look at that one by one as we come to it. Okay. So let's look at the odd magic squares first. Okay, because odd magic squares are much easier to build. Okay, odd magic squares. Okay, let's see how we can construct an odd magic square. Okay, we are going to use a method called the Siamese method. This is a Siamese method. This method was published by Simon de la Lobere. Okay, he published this method in a book. He actually went to Siam and he learned this method and he published this method. Okay, so we are going to use this method to fill in this 3 by 3 magic square. Okay, let's start with the common magic square first. So we have numbers, say 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have already calculated the magic constant. So what is the magic constant? What is the magic constant for this? So we are doing a normal magic square. We already calculated this just now. What is, okay, so this is 3 by 3, right? 3 by 3. What is the order for this magic square?
3.
3, right? So we know that the order for this magic square is 3. So to calculate the sum of the magic constant, we are going to use the formula n into n squared plus 1 divided by 2. So this is 3 into 3 squared plus 1 divided by 2. How much do we get here? 15, right? So we know our magic constant for 3 by 3 square for these numbers is 15. Okay, so that means the sum of each row, each column, and each diagonal should give us 15 once we put it into this square. Okay, so you watch how I'm putting the numbers into this square. Okay, and I want you to see the pattern. Okay, 6, 7, 8, 9. So now let's calculate the sum for each row. 8 plus 1 plus 16 here is 15. This row 7 and 3, 10 and 5, 15. Okay, 9, 10, 15. How about this column? 8, 9, 10, 15. Okay, 9, 10, 15, 13, 14, 15. How about this diagonal also gives us 15, and this diagonal also gives us 15. Okay, because the sum of each row, each column, and each diagonal is 15, therefore we have constructed this magic square using these 9 numbers given. Okay? Yes? So far, okay? Okay, let's look at another example. Okay, I'm going to show you how to do this again. Huh? Okay. Okay, let's say I have a different set of numbers here. Okay, so my numbers are starting from 5, 7, 9, 11, 13, 15, 17, 19, and 21. How many numbers do I have here? 9 numbers. Huh? So this magic square that I have here, what is the order for this magic square?
3.
3. Okay, let's calculate the magic constant or the sum. Okay, which formula are we going to use?
1/2.
Yes, 1/2n into
2
2a plus
D
d into
2
n
S
square minus 1. So what our n is 3. So this is 3/2. Our a is
5
5, correct. Plus d is
2
D is the difference. So the difference here is 2, difference here is 2. Check everything, difference is 2. So D is 2, N is 3 squared minus 1. So what's our answer here? 3 times 3, 9 minus 1, 8 times 2, 16 plus 10, 26 times 3/2 is?
39
39.
Yes, it's 39, which means that once we've put in all these numbers, the sum of each row, the sum of each column, and the sum of each diagonal must give us a total of 39. Okay, so we are going to use the Siamese method to put these numbers inside here. So I'm going to start with the first row. First number, put in the first row, middle square. So 5 goes here. Okay, so after this, we are going to move to the right and to the top. We are going to move diagonally. Yeah, we're going to move diagonally to the right and to the top. Okay, that means from 5, we are going to move up here. We're going to move up here, but there is no number here, right? So if there is no number, you go to the end of the row or column. In this case, it is the column. So we go right to the end of this row or column. So we put the second number here, 5, 7. Okay, and then from 7, we are going to move diagonally to the up to the right. Okay, there's nothing here. We are out of the box. So we move to the end of the row or column. In this case, row. Move to the end of this row. What is the next number we're going to put there is 9. Okay, so from 9, we are going to move diagonally up. We're going to go to 5. But there's already a number here. Because there's already a number here, we put the next number below the previous number. So the previous number is 9. So the next number, we are going to put it below. So we're going to put 11 here. Okay. Now from 11, we are going to go up to the right here. So our next number is there. So we're going to put 13 here. From 13, we're going to go up to the right. So our next number is 15. So 15 is going to be there. Okay. So from 15, we are going up to the right, but nothing there, and there's no row or column there. So we are going to put the next number below 15. So we're going to put it here, 17. Okay, 17. And then also again go up to the right, nothing there. So go to the end of the row. So next number will be 19. After 19, go up to the right. Nothing there. So go right to the end of the column. Okay. So the next number is 21. And we have completed our, and we have completed our magic square. So now let's check. Let's check the sum for each row, column, and diagonal. Okay. So 19 plus 9 plus 11 is 39. Okay. 5 plus 13 plus 21, 39. 15 plus 17 plus 7, 39. This way also 39. 9 plus 13 plus 17 is 39. 19 plus 5 plus 15, 39. Along the column 10, 20, 39. Here along the diagonal here also 39. This diagonal also gives us 39. Okay, so we have placed all these 9 numbers into the magic square with a sum of 39 using the Siamese method. Okay, so can you understand this method?
Yes.
Anybody has any questions?
No.
No.
But
Okay.
confusing sikit.
Is it confusing?
A little bit.
A little bit. Okay, let's do this again. Okay, the much simpler one. We'll go back to the simple one again. Look at it. Okay, let's do this one again. Number 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is 3 by 3. 3 by 3, we have 9 numbers. 5 by 5, we have how many numbers for a 5 by 5 square?
25.
Yes, this is a 5 by 5 square. We have 25 numbers. Okay, so let's start. First number here is 1. So this is the first row. Put in the first row 1. Okay, from here, go up here. Nothing, come straight down. 2. From here, always move this way. You see, we're always moving to the right and up. Okay, from here, 2, go here. No number, go to the end here, 3. 3, you want to go up here, but there's already a number, cannot. So you put under 3, 4. 4, go up, 5, go up, 6. 6, go up, nothing there, cannot go both sides. So put under 6, 7. 7, go up, nothing, go right to the end, 8. 8, go up, nothing, come straight down, 9. Okay? So this is another example that we're going to do, okay? Okay, let's try a 5 by 1. You can do for anything, 5 by 5, 7 by 7, any odd number, okay? And it's not very difficult also, okay? So now we're going to put in numbers from 1 to 25, okay? Inside a 5 by 5 magic square. Okay, let's calculate the magic constant first. What is the magic constant here? Because I'm starting by 1, I can use this formula, right? So this is, my n here now is? 5, yes, 5 times 5 square plus 1 divided by 2. Okay, so this will give me 5 times 5, 25 plus 1 is 26. 13 times 5. What is 13 times 5? 65. Okay, so that means total here now must be 65. So let's start. Okay, we're going to start with the first row, middle box. We always start here. First row, middle box. So 1 is here. 1, go up, come down here. Come down here. 2, right? 2, 3. 3, go up here. Go to the end here. 4. 4, 5. 5, go here, cannot. So 6. 6, 7, 8. 8, go up here, come right down to the end. 8, 9. 9, go here, cannot go to the end. 10, okay? 10, go up here, cannot already number there. So put below it. So 11, 12, 13, 14, 15. 15, go up here, cannot. Both sides cannot. So, sorry, this is 15. 15. So 16. 16, go up here, go right to the end here. 17. Okay. 17 go up, come down here, 18. 18, 19, 20. 20 cannot go here, got number, so 21. 21, 22. 22 go right to the end, 23. 23, 24, go up here, come down here, 25. You see how it works?
Yes.
Yes? You think you can do this?
Okay.
Okay, very good. So this is an odd square, odd magic square. Okay, so we have already seen an odd magic square. We know how to calculate the magic constant. We know how to put in the numbers using the Siamese method.